Good day. For those of you who do not know us, we're the instructional staff for ECE 150. Professors Hiran Patel and Verna Dietl, and Douglas Harder. In this topic, we're going to discuss testing your code. This is the third in a sequence of 6 topics on first C assertions and then code development strategies, including the authoring of skeletons before you start coding, now testing, and this will be followed by a discussion on commenting, using print statements for debugging, and using tracing for debugging. So, in this topic, we will describe how to write a test, at least at this level. We will explain why tests should be written first, that is, before you start writing your source code. We will look at some examples where we write tests for very specific functions, and we will emphasize that all code should be executed by at least one of your tests. Now, first, when you are given an assignment or a project, you will be given a description and requirements. Initially, we may give you many, if not all, of the appropriate tests. But at some point in your life, you will be authoring your own code, and you should be not only writing that code, but also preparing tests for that code. So thus, you should also be considering what is required and how can I test this. Let's take a look at an example. Suppose you are asked to author a function that calculates the median of 3, that is, the middle number of 3 arguments. Here's the function declaration. Thus, in your main function, you can now include a test. So, here we have a skeleton of our program. The median function is not implemented, it simply returns 0. However, in the main function, we call the median with 3 arguments, and we print that together with the expected result given those 3 arguments. So, if your implementation of the median function was correct, your output should appear as 3.5 equals 3.5. If the median function returned any other value, these would not be the same, and you would notice that there is an issue. Now, as you may guess, one test for the median function is not enough. First of all, the median could be any of the 3 arguments. So here I have 3 tests, each of which has the median appearing first in the first argument, then in the second argument, and finally in the third argument. However, as you will see here, I use both positive and negative numbers. Very often students forget to test their code with negative arguments, simply because it's just easier to type in positive numbers. So make sure you try multiple different values. Also, switch the order of the other 2 entries. In the first case, at the top, the median was the first argument. The second argument was the smaller of the 3, and the third was the largest of the 3. So now I have a test where the median is still in the first, but the largest entry is the second argument, and the smallest entry is the third. You'll also notice that I didn't use the exact same numbers. I varied them slightly. Now, what happens if your code is executed when 2 or 3 of the arguments are equal? Well, if 2 or 3 arguments are equal, then the median is the duplicated value. So here's a test where all 3 arguments are equal, and we expect the output to be that value. Here we see 3 different tests where the first and last arguments are equal, then the second and third, and finally the first and second. You will also notice that in all three cases, the odd number out is less than the median. Well, that suggests we should also have similar test cases where the odd number out is greater than the median. Notice that I'm trying not to use the exact same arguments everywhere. And again, that just ensures that I did not accidentally, in my code, deal with one specific case incorrectly. To further on that point, there's actually something called randomized testing, where rather than testing with explicit values like I am doing here, you can also throw in random arguments where you can ensure that one of the three entries is the median. However, the other two entries may have slightly different values. Finally, it's not a bad idea to test some really extreme cases. So here I have three numbers with very large exponents, and I expect the output to be the first. Okay, so here is our new and improved main function that actually runs a significant number of tests on our median function. We can now go ahead and implement our function. Of course, because we're using a skeleton, if we compile our code initially, the output seems a little bit bizarre, as none of the answers are correct. However, as we keep on implementing our median function, more and more of the outputs should appear as expected. So in this case, we finally say that, oh, wait a second, all of our outputs are indeed equal, but the last one is slightly off. Now, always remember that if your output differs from what is expected, there are two possibilities. There might be a bug in the source code, but there may also be a bug in the test. This is the test that failed, even though I believed I had written the median function correctly. Now, what happened here? Well, unfortunately, I saw that the first and third numbers were negative, the second argument was positive. So the median was is either the first or the third. By simply looking at the absolute value of the exponent, I saw that 73 is smaller than 82. The problem is I missed the minus sign. So the first number is actually a negative number times 10 to the 73, which is very, very large, but also negative. But the third argument is a negative number times 10 to the negative 82, which is an exceptionally small negative number. So the correct test would have been to indicate that the third argument is the median of these three numbers. Now, you're looking here and you notice that I have implemented the main function and included there a number of tests, despite the fact that I had not even written the median function. Why should we be writing the tests first? Well, if you write the source code first, what you wrote in that source code is going to influence the tests you write. You expected this behavior when you authored the source code, and so you will put that behavior into your tests. Also, if you made a mistake in your reasoning while authoring your code, you're probably going to introduce that exact same mistake when authoring the tests. It's natural for a programmer to assume that what they have written is correct. And so if you author the function first and then use that function to determine what the correct output is, of course your tests are going to be correct. Well, sorry. Of course your tests are going to match the output of your function. Your tests should be written based on the specifications and the requirements, not on the code that you authored yourself. So, when you're working in industry, it's often standard practice for one person to be tasked simply with writing the tests. They are not involved in the authoring of the code. That job is left to someone else. Instead, the individual writing the tests simply base the tests on the requirements and specifications. You can do the same thing. Working with at least one other student, take turns for each project or assignment where one of the students in your group writes the tests before starting to author a solution. That student can share those test cases with that student's peers. In EC 250, the course on algorithms and data structures, on occasion one student would author a 100-line and even 1,000-line tests for all students to use in the course. That student would author the test. Every single student who used them often got 100% in each of the projects. And that's okay, because each of them did indeed author their code and got their code to execute correctly, and they did so because they had a reasonable collection of tests that would tell them if they did something wrong. Now, funny story, in one case, this collection of 1,000 lines of testing code missed one interesting edge case. So consequently, almost all students in that class got that specific edge case wrong, and we're going to discuss edge cases in a minute. In one case, also, the class actually asked if that one student could get a bonus in the course. And because there were no complaints from any student in the class, that student did get that bonus. It's only fair. That student was acknowledged as having made a significant contribution to the rest of that student's class. So in this course, you are never, ever going to be penalized for sharing tests. We want you to share tests. That will be encouraged. It will actually be appreciated, because if you're sharing tests, you're also helping someone else come up with the correct solution. Just please never actually share your real solutions with your peers. It can be very frustrating. Your friend may promise that under no circumstances will code be copied. However, as we've already seen, there are many different ways to author the same code, and there are many different ways to get a solution that solves even very simple assignments or specifications. And the projects will be significantly more complex. Consequently, your friend who is struggling is going to have a complete different approach to solving the problem. So they may actually not want to copy your code. But when they compare your code and their code, because both of you have taken different approaches, your code does not give them any guidance as to what the correct solution is. And consequently, as the deadline approaches, there will be greater and greater internal pressure for that student to simply cut and paste your solution into theirs and submit it. Yes, they'll probably try to change a few things, but that's insufficient usually to get caught. And so thus, you and your peer will get 0 in that project and minus 5% in the course. Help your peers. Sit with them. If your project is working correctly, then take a look at their project and try to find out what is wrong and suggest what your peer should do to correct the errors or bugs in in their solution. An edge case is a situation where one parameter takes on a specific interesting value that approaches a boundary in the source code. Now, what does that mean? Well, recall previously we worked through an example, and you were asked to do this on your own first, of reversing the digits of a number. So given 9,512 as an argument, the output should have been the digits 9512 pipe 2159. That is, the digits in order and the digits reversed. Given negative 42, the output should have been minus 42 pipe 24 minus. Now, looking at my source code, I noticed that I was comparing something against 0. So if I'm comparing a value against 0 and it halts when that value is 0, then what happens if that parameter starts off with the value 0? Well, I noticed that my code actually would not work if the argument was 0. In fact, what would have happened is the output would have been 0 pipe, but nothing else. Had I not thought to test this edge case, all my other tests would have happily passed, and I would have been oblivious that my code did not work in this one specific case. As you may recall, in the end, I simply dealt with this special case separately. So, in the reverse function, the first thing I did was check, hey, if n is equal to 0, I'm just going to print out what's expected as output and return. I'm done. The rest of the code dealt with any other case. All right, let's say we were writing a function that calculates the greatest common divisor of two arguments. Well, first of all, I'd want to test to make sure that the GCD of n and itself is equal to n. And on top of that, I'm going to test this for both positive and negative values of n, as the GCD must always be positive. Additionally, I should check that the GCD of some random integer, maybe 17 or 32, see if that and 5 times that integer are still equal to the smaller of the two. Notice also that I'm going to test n versus a negative composite number times n, and again, the GCD should be n. Also, from the literature, we see that the GCD of n and 0 is also n, because 0 is divisible by n. But also, the GCD of 0 and itself should be 0. So I should also author a test for this. The GCD of 17 and 32 should equal the GCD of 32 and 17. So consequently, it would be useful to ensure that these two values are equal for various pairs m and n. Finally, I should have a number of cases where the GCD of two integers is equal to 1. That is, they share no common factors, or are similarly, m and n are said to be co-prime. In all of the above cases, I'm going to be checking when m and n are both prime and composite. They in fact should be prime, a composite that is the product of two primes, and highly composite numbers such as, say, 2 to the 4 times 3 times 7 squared times 19. And once again, I should be looking on the web and finding some very large prime numbers and using these in the tests as well. Not just 17, 19, 31, 91, etc. Oh, wait a second. 91? No, that's not prime. Anyway, carrying on. Also, when you are finished writing code, make sure that each line of your code is executed in at least one test. If there's a line of code that is never executed as a result of running your test, then we have a problem because we're not checking to make sure if that code actually works correctly. This is another way of ensuring that your test cases are complete. For example, this function here finds the minimum of 3 arguments. All right, how does this work? Well, if A is the minimum, this entry, this return value occurs. If B is the minimum, then this return value will be executed. However, if C is the minimum, one or the other of these 2 return statements will be executed. Specifically, the first one is executed if A is less than B, but C is less than A. The second one will be executed if B is less than A and C is less than B. So we should, at the very least, have 4 different tests for this min function. Thus, following this topic, you now understand that you should be authoring tests. Yes, we will start by providing you with the tests for your code, but always consider asking yourself, how would you test the algorithms you are implementing? Tests should be written before the code is written and should be based on the requirements and specifications. Also, please do work with your peers. If you do generate some tests, try or consider sharing them with your colleagues. Ensure that all code is tested at least once in some test. Here are some references, acknowledgements, the colophon, and a disclaimer. Cheers!